Hi guys, welcome back to my channel. In this video, I'll be taking you through increasing and decreasing test of a function. As we've learned in our previous sessions, a function is just a changing variable with respect to another variable. Some part of the function may be increasing, while some other parts may be also decreasing, and other points may be constants, called point of inflections. So in this tutorial, our focus is on how to find the interval of a function where it is increasing or decreasing. So I have a problem here to guide us. So determine all intervals where the following function is increasing or decreasing. So the function is a function f of x given as negative x to the power 5 plus 5 over 2 x to the power 4 plus 40 over 3 x to the power 3 plus 5. So let's see how we solve this problem. First of all, when you say increasing or decreasing of a function, remember that the gradient function, if I have a function here, so here's my x, then let's say here's my y, right? So if I have a function somewhere here, right, you realize that this function here starts towards increase, and upon reaching a certain point, will relax, then it will start towards decrease. Again, it will reach at this point and it start to increase. So meaning that a function may have increasing parts and not a decreasing parts. But the case is, how do we know that this part is increasing, or how do we know that this part is decreasing? We use the derivative. Now, the derivative gives us an idea of how the function is changing. So, if your derivative f prime of x, right, if your derivative is greater than 0, meaning that your function is what increasing on that interval. So, meaning that if your change is what positive, means increasing. That is, if you realize that the change of one variable with respect to another is positive, meaning you are going higher, right? But if f prime of x is less than 0, then you say that our function is what decreasing. Our function is decreasing on that particular interval. But a case where our f prime of x is equal to 0, that is what we call point of inflection, and it's also what a critical point. A critical point. So a function will have three parts. Let me draw one section of the function. So this section from here to here will be what? The increasing, right? Increasing. Then this part alone will be what? Constant. You can say it's constant. You can say it's a critical point, right? Or from here to here to be what? Decrease. Decrease. So these are the main parts of the function. And using the derivative, you should be able to find what? The decreasing interval, increasing and constant. So let's solve the problem you have here. So our function is given. So f of x is equal to negative x to the power 5 plus 5 over 2 x to the power 4 plus 40 over 3 x to the power 3 plus 5. So as I said, to find the increasing and the decreasing intervals, you have to find the derivative. That's the first thing to do. So what is f prime of x? F prime of x here, I'm going to get negative 5x to the power 4 plus here, you multiply 4 by here. Remember 2, so let's make it 4 times 5 over 2 x to the power 3 plus here 2, 3, and the 3 will cancel. So 3 times 40 over 3 x to the power 2, 5 0. So I simplify further as negative 5x to the power 4 plus 2 goes here 1 goes here 2, and that is 10x cubed, right? Plus this 3 will cancel this 3, giving me 40x squared. So this is my first derivative, right? So as I said, first derivative test is for testing increasing and decreasing. At this point, I need to factorize something out for simplification. So negative 5 x squared can be factorized, and I'm going to get x, right? Here will be x squared plus, no, as I factorize negative part, here should minus, right? So here should minus 2x, then here 2 should not negative, and this side I had plus 40 squared, right? So I'm supposed to get plus negative. So here should be minus 8 like this, minus 8. Because I'm factorizing negative out of this equation. So here should be minus 8. So at this point, I'm going to get negative 5x squared. Then you have to expand what you have inside here. So if you point this on the calculator, so we mean that what are the factors of negative 8 that when you add, you get negative 2. Remember, you can have negative 4 and 2, right? Negative 4 and 2. They will be factors, negative 4 and 2. So we say that you have x squared minus 4x plus 2x minus 8, right? So let me rearrange it all. Negative 5x squared, I'll have x squared plus 2x minus 4x minus 8. So negative 5x squared. Here I'll get x plus 2, right? Minus 4x plus 2. So I'm going to get negative 5x squared multiplying x minus 4 multiplying x plus 2. So here x will be equal to 0, x will be equal to 4, x will be equal to negative 2. So these are the three values you have got from what? Our derivative. So these are what we call the critical points. So we have got our three critical points. We need the interval over which our function is increasing and over which our function is decreasing. How do we get the interval since we have our critical points? As I told you, if you take one part of the function, at the critical point, on the left side it was increasing, at the right side it was decreasing. Remember. So how do we know that? To do that, you are going to draw a number line. On the number line, you have 0. Here, negative 1, negative 2. Remember, on the number line, we are representing that with our critical point. The highest is negative 2, so I can just bring down negative 3, negative 4, negative 5. Here becomes 1, here becomes 2, 3, 4, probably 5. Right? At this point, my critical points, I have 1 and 0. So I have one critical point acting at 0. Right? Then that is my first partition. Another critical point acting at negative 2. Then the next one acting at 4. Critical point acting at 4. So meaning that I have broken this into different segments, right? So I have set one segment from negative 2 to this side, and that one is between negative 2 and 0. Other one is 0 to 4, then 4 towards this side. So let's analyze this well and find the interval over which our function is increasing or our function is decreasing. So this is what you're going to do. You know, to test for increasing and decreasing, I said our gradient function f prime of x should be what? Greater than 0 for it to increase, right? Then our gradient function f prime of x should be less than 0 for it to decrease. So here we are going to test for f prime of x. Their x is random number, so you select any number here. If you realize that the gradient function is negative here, then you say that this interval is what? A decreasing interval. You take any random number from this interval as well. If it happens that our gradient function is increasing, then or is greater than 0, you say that it's an increasing interval. So from negative 2 to negative infinity, I mean this side, let's select a number other than the critical point because the critical point is 0, right? So let's select any number. Let's say negative 3. You realize that f prime of negative 3, we are putting negative 3 into our derivative, and our derivative we had negative 5x squared, right? Multiplying x minus 4, multiplying x plus 2. So when you do this, you are going to get negative 315, and that is what? Less than 0. So meaning this side is what? Decreasing. So f prime of x is what? Less than 0. Within this interval, other than negative 2 and other than 0, you can pick what? Negative 1, right? So f prime of negative 1 should give us what? 25. And this is also what? F prime of x is greater than 0. Now, this is our third interval. Our third interval, 0 is excluded, 4 is excluded. So you can select any number here. 1 is accepted. So f prime of 1 will give us 45. So here too, f prime of x is greater than 0. Finally, our last statement, f prime of So we can't take 4, we can take 5. Or 5 will give us negative 875, meaning f prime of x is less than what? 0. So using these intervals and these values we got, we can get our increasing and decreasing intervals. So let me write increasing intervals. So increasing intervals, I'm going to have, so from here, that is this segment, from negative to what? Negative infinity, right? Negative to negative infinity. So I'll have negative infinity on the left side for my negative 2. And another, sorry, this is decreasing side. Decreasing. So let me make it decreasing side. So decreasing side. So negative 2 to negative infinity. Then another decreasing side is also the side. That is from this side going. So I'll see 4 toward positive infinity. So I'll have 4 at the minimum, then positive infinity at the maximum. That is decreasing. Now for increasing interval, I'll have the segment. So that is what from 0 to negative 2. No, negative 2 to 0 instead. So I'll have negative 2, then what? 0, right? Remember that our endpoints are not included, the critical points are not passed. Then finally, our increasing will also be 0 to 4, 0, 4, 0, 4. So this is how we find the increasing and the decreasing segment of function, or the increasing and the decreasing test. Thank you for being with me in this video. Don't forget to like, subscribe, and share. See you in the next section as I take you through optimization.